to the, if someone can't see the live feed. So we're going to start by continuing by drawing the bracket. Okay, so it's 19. So that's 21. (16 and 19), so it's 3 millimeters. So I'm just busy with the bracket. I've started with this part there, so I'm focusing on that part there. Now the height of the bracket is determined by that radius there, 27. And I mean the height from the center of the shaft. 27. So we post on the group. I almost forgot. Remember about the roll call. If you haven't done it yet, let me just quickly post it. Now, here's something I want to talk about, and I'm going to be honest with you about this. There's a super, super small radius there and there. So it's not a sharp corner, it's a super small radius. My compass, or I can't draw such a small radius with my compass, and I don't have any stencil to do it. So I'm not even going to try to draw that. I'm going to keep it a sharp corner. So if you can't do it, since it's just such a small part of the drawing, I don't think that you will lose marks. Maybe 1 or half a mark, but I'm not going to spend. What you could do maybe afterwards is maybe just take a freehand and try to make it round. But I'm going to leave it at a corner because working with a radius of 3 is actually difficult for me to do it. So that's my opinion. So I wouldn't be bothered about such a small radius. It won't count a lot of marks if they even see it. I doubt that the marker would. It's such an insignificant part of the drawing. I have to be honest. I think as a marker, I would have missed it. But if they don't in the final exam, it can't be more than half a mark. If it's that much, it could be less. So that's my opinion. I will just leave it. I'm not going to even be bothered trying to draw such a small radius. It's just really difficult. 113. So in Matric, what I've learned over the years is when it comes to Matric work, especially in your final exam, if you know there's something that you struggle with, obviously then you're going to work on it. But if you come into the final test and you know, okay, I'm going to struggle with this thing, it's only a few marks, then just leave it. And then if you've got time at the end, go back to it. So as a Matric, you have to critically think about what will give me the most marks in the shortest span of time in my paper. That's what you're going for. Any other small detail is something you can worry about at the end. So this is my professional opinion as a Matric student. Also start thinking about how to draw faster and where you can take effective shortcuts, to lessen the amount of time you've got, or to use the time you have efficiently. So far I'm just copying the picture, and I'm just copying the outline of the bracket. Just remember which parts we can hatch and which parts we can't. Or shouldn't, not can, shouldn't. Okay, it says it's a 60, so I'm going to use my 60. I just need to add the little circle. It's in the middle, so it's 8. So it's 8. The circle's in line with the grub screw. Then now they don't give us the height directly, so let me just quickly go there. Let me just double check now. I can't see. Let me just zoom in as you can see it. They don't give us a height for the circle. Even on the other, they don't give it the height, but what I can see, it has a radius of 10 and the total height is 17. So if I take 17, subtract 10, I'm left with 5. And it's equal parts top and bottom. So 5 divided by 2, I'm working with 2.5. Now 2.5 you can still do because it's halfway between 2 and 3. So there's 3. There's 2, so it's plus minus 2.5 is about there. Set my compass to 5. Yes.
Your camera has gone out of focus.
Thank you.
Focus left the chat, sir.
I really dislike drawing small circles because my compass usually slips. So something that's also necessary to practice. So I'm going to do my best here, but small circles are horrible. If you've got a stencil for circles, this is where it's really handy to have one. That's way too big. My compass is a bit limited. Let me see if I can quickly grab a stencil if I have one like that. I don't think so. So here's a suggestion from me. If you struggle with the small circles like I'm doing, get a stencil. I'm gonna try this. Let's see. Okay, it's 10, but it's 1-to-1. Yeah. Okay. So. This 5 seems to be too big. Okay, there it is. There it is. Now I'm warning you. I don't use stencils a lot, so this might look horrible. Okay, so that's what I'm saying. You have to practice with stencils if you're going to use it. Okay, that's not too bad. Okay, so make a mental note for yourself. Get a stencil for small circles. It's going to save you a lot of headaches in a test. Don't forget about the center lines. Okay, there we go. Now I just need to hatch it. Okay, this was done with a 60 degrees, so let me do the hatching here with 45. Try to, if possible, to swap out between 45 and 60 and 30 for every component, adjacent component. That will help a lot just to distinguish between the different views or different parts. I'm not going to darken. Oh, I can actually darken here as well. This part of the shaft. There, and then here as well. Now I remember this drawing from last year with the previous grade 12s, and some of them actually hatched this part as well. Just remember, it's not hatched because there's a gap in the middle. That's why. So what you're looking at is the back. It's that part there. That's why you don't see hatching there. And we don't hatch this part because it's a support structure, and the rest, yeah, good. So that's the bracket. Okay, so we've done halfway of the shaft. We've done the bracket, the grub screw, we've done the bracket. Now the next one is the bush. This one. .42, so again, 21. So it's the same height as this one. Okay, nice. This is a smaller component. I think I can do it like this. Okay. Then it's 32, so that's 16. Okay, there's the bush, short and sweet. So there's the bush. Okay, we've got the bush done. Now, okay, yeah, now for the difficult one, the pulley. So I'm going to make use of our planning here, but we'll have to be careful. What I can tell you what's going to happen is this support structure here will be a tiny bit bigger than this support structure, because if you look at the right view, this one is facing, it's perpendicular to the front view. This one is not, so it's going to be squished in a tiny bit. So that's the difference you should see. Bigger support structure, smaller. The rest should look kind of the same. Now, since I've done the pulley already on the other view, let me just focus this again. Since I've done the pulley here already, most of my measurements, I'm just going to project over with my Tsquare, so I don't have to go and measure again because I have it here. So to save time, don't measure. If you have a measurement already on your page, just project it. Don't go and get it again. It's usually quicker just to project. Okay, so this is a bit out of focus, but the focus should be here anyway. drawing from left to right. So I'm going to start there and then move that way. Remember, most of these lines you won't see anymore. It's just going to be left with the outlines. So the bush is 33, and okay, so look at this. The inside of the bush, the smaller part, has a length of 33, and the space within the pulley also has a 33. So that means the bush will fit nice and snug inside the gap here, which makes sense because what the purpose of a bush, it acts as a bearing. So this will be, the bush will have a bit of grease on it. So when the pulley rotates around the bush, it doesn't, it has less friction. So because remember, a pulley is something that has a rope or belt over it to rotate, to either lift something or to rotate something else. So you want a nice smooth rotation. So this bush will fit nice and snug within your pulley. So we can basically draw the pulley around the bush. It also makes sense that there will be a gap between the bracket and the pulley, because if there was no gap, then there will be friction against these two parts again. So the bit of the gap that the bush creates helps to prevent unnecessary friction. Now what I'm now doing, I'm looking for the distance from there to there. So what we're going to do is I'm going to take 54 minus 32, which should give us 24, 22. 22 divided by 2 gives us 11 and 11. I'll add in the hatching when the pulley is completed. Now I'm just going to leave it as it is. So what you're looking at, those two blocks, is the two blocks there. That's basically that part of the pulley, if cut in half. Now here's something interesting. We don't have any degrees for the wedges, so we can't just start drawing the wedges. So I can't do this. I can't just go and draw the wedges. So what I'm going to do is I'm going to draw these two outside parts and connect them to the wedge afterwards. I'll connect the wedge to the already drawn part afterwards. Just want to check the time. Okay, we've got 10 minutes. So let's see if I can at least get a bit more done of the pulley, then we'll end it for today. There we go, the pulley. There's the top, because it's in line of the right view of the pulley, and there's the bottom. Now again, for the spacing between them, they don't just give it to us directly, you have to go and work it out. So it's 24 minus 15, that gives us 9. 9 divided by 2, because that's 4.5, which we can work with. We can work with 4.5. So put 4 and 5 halfway on the line. Now I'm trying to figure out what's the distance there. I know from there to there it's 15, but now we need to find, so they have to, oh, here it is. So it's 15 minus 6 gives us, okay, so it's 9 again. So it's 4.5 again. So it's 4.5. The middle is 6. Then it's 4.5. And 4.5 again. And I'm not going to go and measure this at the bottom of my ruler again. I'm just going to bring it down with my ruler. Now, the spacing there is given by that hidden detail, and they give it to us here 143. So I think the easiest way to get that 143 is I'm going to add it to my right view. Not the whole hidden detail, because we don't have to, but I'm just going to take my compass, divide 143 by 2, which 140, that's 70, so that's 71.5. And I'm just going to make little indications for myself, then project it over. That's, you could have just worked it out, but I think this is the quickest. Then according to the information given, it's 13 millimeters. I'm just trying to find out that distance there. Work out this distance from there to there. Oh, it's the inside. It's this inside angle. We've got it. It's this one. So it's that line there because it comes from there. And then this line here. Finally, we can connect the wedge and the pulley together. Just be careful with the bottom part. As you can see, the wedge only starts there. So compare the two. Let me take it from the top. First, compare the top. There's the wedge, the beginning of the wedge, there, and there's the end. But if you look at it from the bottom view, there's the wedge. Okay, so it's a lot higher, and the wedge ends there. So you just make a note of this. And oh, I'm looking at the wrong wedge. We have to look at this one because we're going to cut it in half and remove this part. So let's look at. So there's the one wedge. I'm going to draw it in red so you can see it. So you'll see that part, and you won't see that part. So that means the wedge will come from check again. That's exactly what I didn't want it to do. Sorry, I made a mistake. Where's my eraser? Oh, here it is. Try it again. So there's going to be a straight line here, and then the wedge starts. Because look again at the red. The wedge is not in the center; it's on the side. There we go. So you see, it's a bit weird, but that's how it looks like. Okay, that's the class for today. Can wait for the bell. We'll continue from here tomorrow when I see you again. So we're almost done with the pulley. I'll link this or I'll share this video as well. That's it from my side. Tomorrow when we're done, we'll quickly take questions if you had any questions so far about the work. See you tomorrow. Remember, this doesn't count for marks. This is just to practice. Thanks, Matric. See you tomorrow.
Bye, sir.
Bye, sir.
Bye-bye.
Bye, sir.
Bye,
Bye,
sir.
meneer.